Ladies and gentlemen, welcome to GraphConnect. So, I think we have an absolutely amazing day ahead of ourselves. But I'm going to start by taking a little bit of a step back and maybe give a little bit of context, set the stage for the rest of the talks. Before that, though, I want to start with the ground rules. And I really only have one ground rule for all my talks, but I do want you to follow it. And sorry to be starting sort of on a strict and negative sort of tone, but I do want you to follow this, right? I do not want your undivided attention. So we have great conference Wi-Fi, and in fact, I want you all to test it, right? So all 1,000 of you, please go online and test the conference Wi-Fi, with which they promised us that it will work. And tweet about this, and give feedback. Let us know if we're doing well or if we're doing bad. The only thing that I ask for you is that you use the Neo4j or the GraphConnect hashtag. So that's it. Cool. At GraphConnect San Francisco last year, I kicked off the morning keynote, since it is the morning keynote, with a little bit of morning gymnastics. And that was so popular that I thought we'd do that right away again. So if all of you could just lean back a little bit and put your arms above your head, stretch, that's right. I'm not going to ask you to hug your neighbor or anything awkward like that, right? And then, if all of you who were here in San Francisco at GraphConnect 2012, if you could please stand up. If you're here at GraphConnect San Francisco 2012, please stand up and remain standing. A few people. And then in 2013, please stand up if you were here in 2013. Awesome. In 2014, please remain standing. 2014, who was here in 2014? A few more people. And in 2015, if you were here at GraphConnect San Francisco 2015, please stand up and give yourself a warm round of applause. Cool. Amazing. So 15 years ago, almost to the day, I was on a plane to Bombay. I was a young CTO of a fledgling startup in Sweden, building enterprise content management systems. And we were struggling. We had the sort of standard stack that we used back in the late 90s, early 2000s. We had a relational database, we had an application server, and then we had a presentation layer. And we were struggling with the relational database. I was the CTO. We had a team of 20. Probably half of my team, 10 people, spent the majority of their time just fighting against the relational database. And I thought that was kind of weird, because the relational database had always been a friend to me in previous projects. I was a fan of the relational database, and I remain a fan of the relational database today. But something was going wrong. And we thought a lot about this, tried to figure it all out. And after a while, we realized that the problem was that there was a mismatch in the shape of the data that we were handling and the abstractions that was exposed to us by our infrastructure. So we were building content management systems, which has a lot of folders with folders in folders and then files in them, which is a big hierarchy or a tree, which is a really, really poor fit for squeezing into tables. So we struggled with this, and after a while we realized there's got to be a better way of representing this data, right? And we thought a lot about what that way would be. And we also figured that we can't be the only people who have run into this. There must be other people, right? So we started looking around for another type of database that used a better abstraction for our problem. And we, Alta Vista'd around and Yahoo'd around and Excited'd around. This was, of course, pre-Google, but couldn't find anything. So after a while, we decided that, we said the famous words, screw it. Let's just build it ourselves. How hard can it be? So as I'm sitting on this flight to Bombay, together with some of my team members, we grab a napkin, literally a napkin, and we start sketching out a data model that we thought would make sense for this new modern world, right? This is, full disclosure, this is not that napkin. It's fully replicated to the best of my recollection, digital copy of that napkin. But we landed in a model which included, it was super simple, included just 3 elements, right? And I've seen the statistics about the audience. 2/3 of you are either evaluating, using, or having Neo4j in production, so this won't be a huge amount of surprise to those 2/3. But 3 core abstractions. We used nodes, type relationships between nodes, and then key value pairs that you can attach to both the nodes and to the relationships. That was a simple model, right? And so if you use that model, you can model a number of different things, right? A very popular example and very intuitive example is, of course, social, right? So here you have a little graph. You have some people. They have relationships between each other. The relationships are of the type knows, right? So they know each other. You can see some properties. You have properties on the node below, right? It says name Anne, I believe, and age 32. We also, very importantly, have properties on the relationships. You can see that we've attached a property to one of the relationships, saying that we've been friends since 2012, right? Very simple model. Starts out simple. It turns out that you, of course, can add other things other than social. Social may be the most intuitive example for graph databases, but it's far from the only example. So you can add, in this case, we're adding some gardening tools here. We can add new types of relationships. Now we're not saying that I know someone, but I'm selling this tool over here, and maybe someone else is viewing this tool or placing an order of this tool, and all of a sudden we've built sort of a, Facebook meets Craigslist kind of application using just those 3 very simple abstractions. That's a very powerful model to be able to easily evolve and represent a lot of information, a lot of new types of applications. Very powerful. What's even more powerful, though, is if it's wrapped in an infrastructure that will allow you to scale if you go from just 4 or 5 nodes to 1 billion nodes or 10 billion nodes or even more. And if we have this, Craig's book application, right, and we have 4 or 5 people, that's valuable. If you have 1 billion people, this is a $10, $50 billion company, right? Very powerful, just built on these 3 simple concepts. So what started out on that napkin, 15 years later today, is now an industry. So you have industry analysts like Forrester saying that it is the killer app for big data, and saying that over 1/4 of all enterprises will be using graph databases in production just 18 months from now. 18 months from now. Which I think is very, very powerful. Their friends at Gartner say that it's the single most effective competitive differentiator outside of getting data into your data platform. Very, very powerful. Those are analysts and pundits and industry experts, but this is also reflected in the real world, people who actually use the database. And we have some absolutely super amazing and passionate community users, many of which are here in this room, that are using this every day and getting a lot of value from it. If you look at it from a sort of quantifiable perspective, there's a site out there that I monitor fairly frequently called DB Engines, which basically does what I used to do manually a long time ago, which is look at tweets about new databases and tweets and LinkedIn profile and Google PageRank and a number of signals to compute a score around adoption of databases. And if you look at that, the relational database has been pretty flat over the past few years. There's a number of alternative databases that have been growing significantly faster. But graph databases over the past 2 years have been going faster than any other database in the history of, out of all the new types of database that we have today. I think this is pretty outstanding. So the question then for the for the curious mind is, why is this happening, right? Why are graph databases taking off, right? And I think there are a number of things. But at the end of the day, the core fundamental principle is that a lot of people have discovered that if you have data in isolation, that is very valuable. But connecting data in isolation is also very valuable. This is what's called graphs, and we have this saying where we talk about graphs are eating the world, which is a trend that started out in the consumer web. In the late 90s, really, was the first company that came along and said, hey, I'm going to reimagine my business around relationships in data. That company was Google. They did exactly the same thing as all the other search engines, the 50 search engines that existed at the end of the 90s, except they also looked at the graph. They took the link between documents and they ranked the search results based on that. And that one innovation is what catapulted them into completely dominating their industry. And what we're seeing right now very, very clearly is this trend that started in the consumer web is now spreading to finance and to retail and to healthcare and to healthcare. Wait, to healthcare? Twice to healthcare and to media and all over to all these traditional industries. Very powerful trend. Another thing that we've seen over the past year or so, as graphs are going mainstream and becoming more adopted and more used inside of traditional organizations, is that we've seen a couple of key use cases emerge. And these are examples of that graphs are being used more popularly than maybe in other situations. And we have a number of them here on this list. I'm going to very quickly give you a snapshot of what people are using today with graph databases. So a very popular one is real-time recommendations. And real-time recommendations, it's all about the people and the products that they buy and analyzing behavior and make recommendations based on that. Very graphy use case. And a great example here is Walmart, which has been a Neo4j user for quite some time now. Real-time recommendations. Master data management is all about working with the master data in your organization, and the master data breaks down into your employees, your customers, your products, your suppliers, and a lot of that data is actually very, very connected and very graphy. A great example here is Cisco. Cisco is actually giving a talk this afternoon, not about their master data management. There are several projects at Cisco using Neo4j, but about another use case. But it's a very, very fascinating application of both master data and graph-based search that Cisco is using Neo4j for. Fraud detection, one of the most powerful uses of graph databases, all about finding patterns in large amounts of information and doing that in real time. It's also one of those where it's hardest to get someone to talk about it because people generally don't want to talk about how they detect fraud. But it's a very powerful use case. Graph-based search is maybe the original consumer web use case, what Google did when they took a relationship perspective on search. So this is in a situation where you have an existing text-based search engine, maybe Elasticsearch or something like this, and you use the graph to rank the search result and enrich them in some way, shape, or form. Lufthansa is using Neo4j for this, to manage all of their in-flight content, the rights and rules and regulations and royalty and IP around that is actually a huge, complicated mess that they need to search on from a graphy perspective. And then network and IT operations. Network is a good hint. If you describe anything as a network, it's very likely a graph. And obviously, here you have nodes that are compute resources or storage resources or something like this. And then the relationships are, of course, whether they're connected over the network, right? And you can do impact analysis in this. And you can do root cause analysis, you can do failure scenarios, etc. So we have a lot of big customers that are using, for example, HP, whose customers in turn are the really big telcos. And they're using Neo4j for exactly those kind of things. And then finally, identity and access management, which is actually related to the absolute original use case for which we conceived of Neo4j. Which is, I mentioned the files and folders that we were working with in the enterprise content management system, but we also had a hierarchy of users that belonged to groups, and groups belonged to other groups. And then you had to connect the group hierarchy over here with the content hierarchy over here, which of course created a big connected mess, right? And this is today a very popular use case outside of finance, but also inside of finance. So those are some really popular use cases for Neo4j that we've seen emerge over the past 12 to 18 months and are part of sort of this trend where we're seeing graphs going mainstream. These are all huge companies. I mean, who did we mention? We mentioned Walmart, we mentioned UBS, we mentioned Lufthansa, we mentioned Cisco, huge companies. We're not just used for big companies. We believe, of course, as a startup ourselves, we think that some of the next decade's, UBSs and Ciscos and Walmarts are being built today. And we want to make sure that they are powered by graphs because we think that is very valuable. So we have a startup program, which I want to make sure that I highlight since we're here in Silicon Valley, where if you're a startup, you have less than 3 million of revenue, you can get access to Neo4j Enterprise for free if you're less than 20 employees. We have 2 tiers, less than 20 employees, completely for free. Less than 50 employees, we have a very aggressive startup discount. And some alumni of this program are companies like Medium and 53, which Andreas mentioned previously, and I think we have a talk from 53 later today. So that's a little bit of setting the stage, but we also have a number of, I think, very exciting announcements for you today. We have 3 announcements and then 1 bonus topic. And the first one, I think, warm up your hands because I think this one deserves a big applause for the 2/3 of you who are using Neo4j today, because as of a few minutes ago, Neo4j 2.3 was released. Woo! And in order to give you a little bit of the lowdown on Neo4j 2.3, I'd like to invite up on stage my friend and colleague, Philip Rathley, Head of Product for Neo Technology.
So a lot of you are here because Neo4j is fast. And Neo4j can be very, very fast for the kinds of queries and the kinds of problems that Emil's talking about. And speed is important, right? But speed, you can run fast 1 query at a time. And that's not what these companies are doing. They're running many, many queries at a time. And that gets into scale. Neo4j 2.2 scales well. A lot of these customers are using 2.2, 2.1, even some older versions. And scale breaks down into things like the number of queries, the size of your data, how big your queries are. And there are many things in 2.3. It's, I would say, the biggest release we've ever launched. And the thing I'm most excited about is how much better it scales while continuing to perform. The way to think about it is that Neo4j 2.2 is designed to handle your fire hose of data. And 2.3 takes it a step further to handle your torrent of data. And how is this done? How did we do this? We came into the year, into 2015, with Neo4j 2.1, where at the very lowest level, I'm going to talk about the caching and how the whole caching layer works. You have a native graph storage engine, which takes care of storing the graph in just the right way on disk. And then, of course, when you're running queries, you want to be as much as possible in memory. And there's memory mapped I/O that was used as a first-level cache, which gives you pretty good throughput. But then it's not fast enough. We discovered for graph operations, well, for some kinds of database management systems, you can actually get the kind of performance you need for just bringing back single things. For doing very graphy, highly connected kinds of workloads, it's not fast enough. So we built another layer of cache on top of that we call the object cache. And the object cache sits on the JVM. And the JVM is very good up to a certain point. But beyond that point, as you get from your fire hose into your torrents of data, it's not very happy when you start taking massive amounts of data and churning it in and out. At the same time, memory mapped I/O is limited when it comes to very, very, very highly concurrent write operations. And so in Neo4j 2.2, in February of this year, we essentially released our own page cache, specialized low-level cache. Instead of using the default OS functionality, memory mapped I/O, we released a highly optimized page cache that increased write throughput by about 10x for highly concurrent workloads. What that's still left, though, is the object cache and the JVM as a limiting factor as you get into higher levels of scale. And what I'm very pleased to announce today is that after nearly 2 years of R&D, we were able to tune this page cache so that it's as fast or faster than the object cache, meaning we were able to move the entire cache off heap and, number one, reducing the redundancy, and number two, leading to much, much higher levels of read concurrency. So we're super excited about that. Another important factor is how the database behaves when you're really just trying to push the limits. Now, every computer system, if you throw enough stuff at it, it's going to break, and it'll break in all sorts of nice and colorful and wonderful ways. And we love to torture databases and do this inside of the lab. And I'd like to talk about what happens when you really hit that limit and try to break 2.2, and what happens when you try to break 2.3. So we ran some tests, and here you have a cluster, 3 instances, which is a pretty typical size. Another interesting fact about Neo4j is you don't need hundreds of machines in order to do really, really heavy lifting stuff. 3 machines can do quite a lot. And it's a stacked graph, so you can see incremental workload coming into the graph, and it's just stepping up. So basically we're saying we're going to run the workload, step them up, step them up, step them up, to a completely unreasonable rate until we basically crush the machine. So what happens with 2.2, and what we're focusing in on is JVM behavior, and specifically garbage collection, and the JVM, when you start pushing it, it starts to need to clean up. It goes into GC pauses, and this kind of activity is not good, of course. And this is what happens with 2.2. So scaling is limited to a certain point, and the JVM is a key bottleneck there. So just for fun, with 2.3, we said, let's double the workload. Let's take that unreasonable workload, multiply it by 2, and see what happens. And this is actually what happens. This is the garbage collection profile. So that's a massive, massive difference. So for all of you who are doing serious work out there with Neo4j, 2.3 is going to be an amazing, amazing thing. Those tests happen to have run on some EC2 clusters, but Neo4j can run on all sorts of stuff. It can run on small boxes, it can run on very big boxes, it can run on clusters of horizontally scalable, very small boxes, supports all sorts of OSs, and can run in the cloud and on all sorts of cloud platforms. And I'm happy to announce today, as of this morning, Neo4j also officially supports Docker. We have an official Docker distribution that's out there right now with 2.3. A platform I'm very, very excited to announce today, another major announcement, is Neo4j on IBM Power 8. What's really impressive to me about the Power 8 platform and all the engineering that IBM has done is that both at the low end and the high end, you're able to have incredibly efficient, incredibly powerful hardware to offer you a choice of scale up or scale out. As of today, Neo4j 2.3 officially supports Power 8 Linux, both Red Hat and Ubuntu. And the thing that's especially impressive about this hardware and very, very relevant for graphs at the ultra high end when you're really pushing the limits is they have this incredible I/O technology where, much in the same way that GPUs came into being as specialized processors for handling graphics, offloading work from the CPU and providing much better graphics performance, IBM has done the same thing with I/O. They've created a dedicated card called a Cappy Flash controller that will handle flash at 10 times the throughput, near memory latency for 40 terabytes plus of flash. So these machines actually, each machine, and you can cluster however many you want, each machine has up to 56 terabytes of extended RAM, and it's extended RAM because the flash is so darn fast and the throughput is so enormous that it's almost like accessing RAM. This technology we're just going into beta in this quarter, and if it's something you're interested in learning about, IBM has a booth in the corner. They're a gold sponsor today, and really proud to have participation here, including from Brad Breck, who's flown in from Rochester. He's one of the inventors of a lot of the key technologies here, and really proud to be a part of this. There's a lot more in 2.3. As I mentioned, it's a huge release. There are a lot of other things, and please go discover them. It's up on our website. It's up on Docker. It's up in all the usual places, so please go and take it for a spin.
Cool. Thank you, Philip. I think 2.3 is going to be such an important release for all of you doing real work with Neo4j, having it in production. I think it's going to be absolutely mind-blowing. It is also the last release in the 2.x series. And today I'm going to give you a little bit of a sneak peek on specifically one feature that I'm personally very excited about in the 3.x series. So I'm going to get back to that napkin. So what that napkin represents is a data model, which is really an abstract concept, an abstract data model with nodes and relationships. So after you've designed that, you kind of need to figure out also, okay, we have the abstract data model in theory. How do we expose that to developers? Because if developers can't build applications with it, there's really no point in it at all in the first place, right? And so we've done that, of course, for a while. And our first attempt at this, which really we used for about a decade, was the embedded Java API. As some of you know, our heritage, our legacy, is as an embedded Java library database. And so we exposed the data model through a standard Java API in process, etc. In 1.x, we introduced the client-server deployment model, where you can use Neo4j as a server, the way you would think of MySQL or Oracle or anything else like that, and a RESTful API to communicate with Neo4j. 2.0, in 2.0, we made Cypher a first-class citizen, and we said, okay, our strategic bet is on Cypher as the future surface of working with the property graph model. And we made that a very inherent part of the 2.0 release. And now we're taking the next step, where we're saying that, okay, we have this RESTful API, we have Cypher, which is amazing, we love, but what we really need to make this a very unified and consistent story is official drivers. So what I'm going to talk to you a little bit about today is the Uniform Language Driver project. And if you look at where we are today, there are a number of things that we want to address with this. The first one is that we want a convenient, so very, very low-friction way to use, and high-performant way of connecting to Neo4j in the client-server deployment model, right? So that's the first one. And the second one is that we want a consistent surface across languages, which is not there today. If you look at an example, this is a Quora post from about a year ago when someone knew they were going to program in Java, right? So what's the best way to use Neo4j from Java? Is it either calling REST functions directly, using the REST binding, using the Neo4j DDBC driver, or using Spring Data, right? And they actually left out one option, right, which is the embedded API, right? And obviously, there's room for improvement here, right? We want, if you know your environment, there should be very clear and crisp answer from us in terms of what surface you should use to connect to Neo4j. If we look into our documentation, this is what you would see recommended for 2.x, which is a client library called Jersey, which is one way from Java to access a RESTful API. This looks kind of messy, but it's a very powerful API. It's the API that you would use to connect to any RESTful service. But however, it is not optimized for Neo4j. So what we're doing here is that we're just getting a list of users. In fact, I think it's even a list of usernames. Match all the users in my database and return their name, right? But in order to get to that, there's a lot of syntax that you have to go through. In fact, we're even parsing JSON here. We're not maybe syntactically parsing JSON, but if you look inside of the bottom where it says for, map, in, etc., we're structurally parsing JSON, right? And this is a very awkward way, of course, of getting a pretty simple query across the wire. So in 3.x, this is going to look like this, right? So you have a driver, you get that somewhere, you connect, you throw a connection string out there, you get a session, you execute some cipher, you get the result, and you're off and running. Super, super simple. This is in the client-server deployment model. If you use embedded, the code is going to look like this. That's right. The code is going to look like this. Identical, right? There's going to be some kind of way of getting access to that embedded graph database driver. But other than that, it's the exact same surface. So now for the first time, really, since we designed the API for Neo4j, you're going to be able to have a consistent surface between a client-server deployment model in Java and the embedded one. So you can run on your laptop, develop locally, use embedded for performance and convenience, and then deploy on a cluster of Neo4j instances, all with the same code. I think this is pretty cool. We're also simplifying the drivers and making them more consistent across languages. So if you look at a similar, not identical example, but a similar example in JavaScript, it looks like this. I left out the for loop because I was putting together the slides last night, and my CEO coding skills don't extend to iterating in JavaScript. But it looks like this, right? So super simple, right? And if you look at the same example in Python, it looks like this, right? So very, very, very similar. And I think that's very powerful. So a couple of things, key features as part of this project, right? So the first one is that we're now going to have official drivers for popular languages. And we're going to launch with a few. We're going to launch with Java, with .NET, with JavaScript, and with Python. But over the course of 3.x, we're going to add more. And we're working with all the driver authors out there to make sure that the languages that we provide are not languages that already exist and with a high-quality driver. So that's the first one. And the second one is that we're going to have a unified conceptual model. And this, in my mind, really breaks down into two things. First off, it is going to be a very strict and well-defined type system in Neo4j, which is not the Java type system, which is what I originally said, right? And when I say type system, I mean all the stuff that you can add to a property. What are those values, right? Strings should obviously be there. I mean, you got to know that. But then after a while, it's like, wait, what actually should we be able to accept as part of a value in a node, right? And the way that I kind of decided is that, well, whatever is okay in Java is what I said, right? And where we are today, that's not good enough anymore, right? So well-defined type system with specific mappings in all, well-defined mappings in all popular programming languages. And then it's also what I call the driver model. I don't really have a good name for it. But basically, those are all the other abstractions that surround a driver, right? So things like a transaction, or a session, or a driver, or a statement, or a connection. So when you look in the Neo4j reference manual, and it says, take your popular, whatever your favorite driver, and get a statement out of that one. Then that's going to mean something for all languages, for all drivers, and it's going to mean the same thing for all languages and drivers. Very, very important, I think. And then we're going to have a way of writing stored procedures in Java. So for those of you who are already familiar and sort of experts at Neo4j, this is really unmanaged extensions ++. Unmanaged extensions are great. There's a number of super powerful things you can do with unmanaged extensions. But one of the problems is that they kind of exist in an out-of-band situation where most of your code uses cipher and you throw that over the wire to the REST endpoint. But then when you invoke an unmanaged extension, you kind of have to go elsewhere, right? And you invoke that through using the REST API. So that's not a great way of working with things. And with 3.x, there's going to be a cipher keyword where you can just call a stored procedure that you've defined in Java. So it's going to be all cipher all the way. It's all backed by a very high performance on-the-wire protocol that we call Bolt, which is binary. And it's completely stream-based. So it fits very well into sort of a reactive world, where today, sometimes you get into a situation where you throw a query out there and you can't really parse the first result set, the first result in your result set, without parsing the entire result set. And with 3.x, you're going to get a stream back of just individual elements. And then finally, in order to ensure consistency, we're going to launch a TCK, or a technology compatibility kit. which ensures consistency across drivers. So that's probably the feature in the 3.x release that I'm mostly proud of and mostly excited about. And it's going to be launching in early next year in 3.0. And it's really all based on one thing. It's based on Cypher, right? And I've mentioned Cypher a couple of times. You can think of Cypher as the SQL for graphs, if you will. It's a declarative query language that it's the third language that we've invented for the property graph model, and we think it's awesome. It's pattern-based, so you describe a pattern using ASCII art, if that means something to you. And then you throw that little pattern over to Neo4j, and it's going to execute and find instances of that pattern. Very, very powerful. It's 10x more productive than the old embedded Java API. And users love it. We have a lot of people, is it the best thing since sliced bread? Yes. Okay, maybe not, but at least it's better than English, according to this guy, right? Which I think is that's a pretty good comment, I would say. And if you look at it, it's kind of interesting. We talked before about sort of the growth of the graph space and really what's been happening over the past couple of years. And it's a very interesting correlation because the graph space starts taking off exactly the time when we made Cypher a first-class citizen of Neo4j, right? Correlation is not causality. We're all data geeks, so we know that. But I do think that there's a huge contributing factor to the graph space truly taking off and going mainstream in that we made available a good, high-quality query language for graphs. So I think this chart here is a testament to really the value of a declarative query language. But I think it also speaks to a space that is going mainstream. And that's some of the things that we talked about before when we see all these big traditional companies now adopting graphs to sort of reimagine their business along relationships in their data. And I kind of think that we right now are at the point where the relational database was in the mid-'80s, right? There's a bunch of vendors out there. They were all really working really hard at implementing the relational paradigm in the best way. They invented all kinds of amazing technology in order to store it on disk. And they also invented ways of interacting with that, right? And if you look at the landscape today, in the graph landscape, there's a number of ways that you can interact with graph databases. We love Cypher because we think that's the best way, but there's a number of other alternatives out there. But one of the key trigger points in order to make the relational space go mainstream was, of course, that all the vendors eventually sort of came together and started to collaborate around a structured query language for the relational database, SQL, right? And I think that we're at exactly that moment right now in the graph space. And that's why I'm super, super excited to announce a new project, which is called OpenCypher. And OpenCypher is an open source project that makes Cypher available for anyone to implement. And anyone means tooling providers, and it means other graph database vendors. We think that Cypher is one of the prized possessions that we have. If you talk to users of Neo4j, many of you in this room, and you ask, what are the top 3 good things about Neo4j? Cypher is almost always one of those 3 things. But we believe that a rising tide lifts all boats. And our goal is to make the entire graph space grow really, really huge. And we think that now is the time to collaborate around a standard open query language for graphs. This is going to give you a number of interesting properties and characteristics and benefits. The obvious one is vendor independence, right? So I talked to a lot of big CIOs, big company CIOs, and a number of them now, I don't say not all of them, but the vast majority today see the massive value that they can gain from graph databases. And a lot of them are adopting it, but some people say that, well, you're a tiny, 100+ person company. What if you go out of business? And I'm like, well, we're open source and this and that and stuff like that, right? But they really have a company policy to only work with standards, right? So ways of accessing data or other things where you have multiple implementations of this. And this is a huge part of that, right? Skill set reuse for all 1,000 of you here today. You can all now sign up for the advanced Cypher class tomorrow. Okay, you can't do that because it's, you know, I think we only have maybe 30 seats or something like that. But you can truly commit to Cypher, to learning Cypher, because that's a skill set that you're going to be able to use, you know, on Neo4j, but also across other graph implementations. And ultimately, I believe this is just the best way of growing the space at large. So we're not doing this alone. We've been testing the grounds. We're announcing it now, and it will be available over the next few months as we get all the artifacts in place and make sure that we get all of the code in place so that we can publish it under an Apache license. And we're going to publish a couple of different things. We're going to publish a reference implementation, right? So that it's, if you're a graph database vendor, you can just implement a few SPIs and bam. After a day or so of development, you're going to be able to accept Cypher queries. We're going to publish a specification, an open specification. Thank you. And we're going to be publishing a TCK, a way of running a comprehensive test suite of Cypher so that you can say that, yes, I'm Cypher, I don't know, 1.1 compliant, 1.2 compliant. But we're not doing this alone. So we're talking to a number of players in the graph space, and one of them is Spark. And I'm sure all of you here have heard of Spark. Maybe some opinions differ. I personally think that Spark is going to be completely dominating the entire analytics space for at least 5 years. At least 5 years. And people talk about it as a replacement for Hadoop. That's a naive view, but it's at least a replacement for the MapReduce layer in Hadoop. IBM says that they're going to train 1 million data scientists on Spark. And we're now working with Spark and with AmpLab to make Cypher the default and the surface for graphs on Spark. This is, I believe, we cannot overestimate the impact of this announcement. So super excited about this. But it's not just sort of open sourcey, you know, small hippie companies that are embracing Cypher. We also have some other big guys that are really saying, look, Cypher is the way that makes sense for graphs. So I'd like to welcome on stage my good friend from a tiny little company called Oracle, Dan McCleary. Welcome, Dan.
Hey, Emil.
How's it going?
I'm your representative from the 80s.
Yes, exactly. Good line. I'm a representative from the 21st century.
What is Back to the Future Day?
Right? Yeah, that's a good question. So this is a graph conference. You're from Oracle. Oracle Open World is next week. Is this really the right conference?
I did not get lost on my way to Moscone Center. I'm here for a purpose.
Yeah.
And part of that is to really talk about how excited we are both about the graph space and the work we're doing there, and then also about OpenCypher and what that's going to mean for the community. So you know, in fact, that earlier this summer, we launched a product, Big Data Spatial and Graph, which is actually looking at large-scale community analysis and complex analysis of graphs in the big data space. But one of the things we're really interested in is how do we make those graphs more operable to users? How do we provide the experience that Neo users have, in fact? And so, you know, getting behind something like OpenCypher is an obvious thing for us.
Awesome. So you've been 4 or 5 years with Oracle. Who are you? Why are you interested in graphs? Are you sort of the odd fish at Oracle?
Well, I'm a pretty odd fish, yes.
Yeah.
But so in a past life, when I was doing my postdoc, I did a lot of community analysis work on large-scale graphs, proteomic graphs, metabolic graphs, things like that. And one of the things that I saw a real need for was for complex analysis of graphs, for pathfinding in graphs. It would be great if there was a graph database. Well, you know, you're a postdoc at a university. You don't necessarily know that these things exist. And had I known that there were such products, I might have pushed the lab in that direction. But we certainly see a need at Oracle, and I see a need as a person coming from a researching life to provide more and more functionality on top of graphs, to bring graph analysis to more and more use cases. And so that's what gets me personally excited about it, and part of the reason that I was so excited to talk to you about some of the things you're doing.
So you know, OpenCypher is all about graphs and querying graphs, right? Why not SQL? Why wouldn't we use SQL for this?
Well, why not SQL? Well, yeah. It's in fact very much tied up with what the paradigm is. As you mentioned, for the RDBMS, SQL was a huge benefit. It was a huge benefit for Oracle. We wouldn't have become as massive a company as we were it not for open standards around SQL. And SQL well models relational algebra, and that's why it's such a powerful declarative language. However, when we talk about the graph space, when we talk about your napkin, SQL and relational algebra does not well fit that napkin without getting us into nasty recursive with clauses or massive null costs on tables. So we need something different. And I think a lot of the people here would probably stand up and say, Cypher paradigmatically fits the way we think about property graph. And as we've been so helped by open languages over our long history, we look at the advent of OpenCypher as being tremendously beneficial, not only for the community of users, but for our customers and the graph industry in general.
Awesome. So you've been watching Neo4j in the Cypher community for a while now, right?
Yeah.
What's your take on the community?
So first, I think
this is your moment to give some love to the audience.
Well, first of all, I'm excited to see so many people in one space who are all passionate and interested in graph. I think it means a tremendous amount, not only for people's interest in graph technologies, but more importantly, I think it's going to be transformative to the industries that we're all in. Because as you called out earlier in the day, there are so many use cases which can be completely reinvented and completely enhanced through graph-based thinking that I think that the Cypher community and these people here are going to be transformative in analytics going forward over the next 5 years.
Awesome.
Yes,
yeah, that's right. That's right.
Yeah, it's on you guys. Come on.
Cool. Any sort of concluding things you would like to say to the audience?
Well, first, I'm excited you're all here. We're excited about OpenCypher. I hope you guys are as well. And if you have a chance, check out our new product, Big Data, Spatial, and Graph. Some of the analytics libraries are available for free download, in fact. And if you have questions, come up and talk to me. Otherwise, enjoy the show, spread the word, get other people interested in graph.
Awesome. Thank you, Dan. Please give him a super warm round of applause. Thanks very much. Cool. So we have Spark with Databricks, and we have Oracle, and we have Neo4j, but we're not alone. So we have several other organizations that are committed to OpenCypher. And this is truly just the beginning, and I hope that you will go out and spread the word about this and ask your favorite graph implementation, if that's not Neo4j, which is okay if it is, to start using Cypher. Cool. So that's that one. We're getting towards the end of the hour, so just a couple of sort of closing thoughts. I think we're now at the point where it's it's undeniably clear that we're entering the connected age, right? Everything is going to be connected. People will always be connected, and devices will always be connected, and things will always be connected. And if you look at what industry analysts and experts are saying, they're predicting an absolute explosion in the growth of connected devices over the next few years. And I really want to applaud all of you in here, because you're on the right side of history, right? So what we're doing right now, as the world is becoming more and more connected, that is going to change our software, our lives, our planet. It's going to change all the data that we work with. So the skill set that you're learning today, and specifically Cypher, of course, I truly believe is a skill set that has only become increasingly important over the years to come. And it's kind of interesting, actually, because if you look at all the sort of industry pundits, and you look at how many connected devices are going to exist by the end of this decade, they actually converge around a number, which is around 50 to 75 billion of connected devices. And that's a lot of devices, obviously. But what is particularly interesting about that number is that it's also same order of magnitude as the number of neurons in the human brain. Sort of the best guesstimate we have right now at the number of neurons in the human brain is 68 billion neurons and 200 to 300 trillion synapses between them. And I'm, of course, always very excited when I have an opportunity to show this picture, because I think it's sort of the ultimate best database out there, right? The human brain, it doesn't just store data, right? But it makes sense of data. and that is very related to how we think of the world and our mission in the world, help the world to make sense of data. There's a number of databases out there that are amazing, and they're good at sort of store retrieve, right? You store one piece of information, you get that piece of information back later, at scale and high performance and all those really valuable and important things. But we have much higher aspirations for Neo4j than just flipping bits on disk. We want to give you an opportunity to analyze that data and really make sense of it and change how you think about that data, because I think that has truly the power to transform your business and take it to the next level. I have one sort of thing that I always conclude my GraphConnect keynotes with, and it's your homework. I started out with one ground rule, which I hope you've followed, and I don't know if the network has held up, but I hope it has. It would be very lame if at GraphConnect you weren't able to connect to the internet. But I also want to conclude with one homework, right? Which is very similar, right? So we're all graph people here, right? And fundamentally what sets us apart, compared to any other data model out there, is relationships, right? And in fact, if you look at a very popular data model called the document data model, it's exact semantic equivalent of using a graph database without the relationships, right? But when you walk out of this conference today, don't be a document database. Don't be a tragically isolated document. Create relationships. Talk to your fellow people, your fellow graphistas. Strike up a conversation. Ask, hey, have you used Neo4j? Or what are you using it for? What do you think is most amazing about that? And just strike up a conversation and form those relationships. So that's ultimately my homework for you throughout this day. I hope we're going to have a fantastic conference for you. And please remember to connect. Thank you very much.